Baik, Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Today, I would like to present about the condensation material. But before starting this presentation, I would like to introduce myself. My name is Haikal Ramadhana Akmal with student ID 2009. So, our, our case study here about the removal of the volatile organic compound by stereogenic condensation followed by adsorption. So this is my reference about the removal of volatile organic compound by stereogenic condensation followed by adsorption. Here, this is my reference. So for the study overview, the VOC removal using hybrid technology, combination of synergenic condensation and adsorption, the focus on high efficiency removal and industrial emission control. And this study investigate the removal of volatile organic compound using a hybrid system combining synergenic and condensation and absorption. The objective of achieve high removal efficiency for industrial exhaust stream containing organic pollutant. Synergenic condensation is applied as a primary treatment step to significantly reduce the VOC concentration before filter purification. This integration improves the system performance, reduce load on secondary unit, and enhance the overall efficiency. The volatile organic compound or VOC, uh, the definition of the VOC, like the source from the industrial solvent and fuel, environmental and health impact, and need for the control technology. For the definition of the VOCs, the volatile organic compound are organic chemical that easily vaporize, uh, vaporize at the ambient condition and contribute to air pollution. They are commonly released from the industrial process such as solvent use, fuel combustion, and chemical production. This compound pose serious environmental and health risks, including the performance of the photochemical smoke and toxic exposure. Therefore, the effective and the VOC control technology are necessary to meet environmental standard and regulation. Next, we jump the principle of the condensation. The first one is the phase change from the gas to liquid. Next, about the cooling below the dew point. Next, independence of the on the temperature and pressure. And the last one is the separation based on the volatility. The condensation is physical separation process in which vapor is converted into the liquid by lowering temperature or increasing the pressure. This phase change occur when the gas reaches its dew point. The efficiency of the condensation depends on how far the temperature is reduced below the dew point. The lower temperature increases the condensation rate, enabling the more effective separation of the VOC from the gas stream. Next, we jump to synergenic condensation concept. There is main point here. The first one is by the extremely low temperature operation, use of the refrigeration of liquid nitrogen, high VOC recovery and efficiency, and suitable for high concentration stream. The synergenic condensation operates at the extreme low temperature, often below than minus 100 degrees Celsius. To condensate the VOC efficiently, such as low temperature allow even low volatility compound to be captured. This method is particularly effective for treating gas stream with a high VOC concentration. It can achieve near complete removal when designing and operate under optimal conditions. So we jump into the working mechanism. The cooling of there is four main point here. The first one is the cooling of the gas stream. In this process, the VOC containing gas stream is cooled using thermogenic system until the compound reach their condensation temperature. This can result in the transformation of the VOC into liquid form. So the condensed liquid VOC are collected and removed from the system, while the remaining gas is sent to additional treatment. This ensures the maximum pollutant removal efficiency. Next, we jump into the factor affecting condensation efficiency, include temperature level, pressure condition, VOC concentration, and gas flow rate. The temperature is the most critical parameter affecting the condensation efficiency, as lower temperature increases the fraction of the VOC that condense. Achieving the optimal temperature is essential for the effective operation. The other factors such as pressure, gas flow rate, and initial VOC concentration also influence the system performance. This variable must be carefully controlled during operation. Next, we jump the energy requirement. The synogenic condensation requires significant energy input to achieve extremely low temperature. This results in high operational energy demand compared to other control technologies. Despite the high energy consumption, the process can be economically justified when the high removal efficiency or VOC recovery is required. Optimization is needed to balance cost and performance. Next, we jump to advantage of the synogenic condensation. There is 4 points here. The first one, the high removal efficiency. Next is recovery developable VOCs, and the third one is the no secondary waste, and the last one is suitable for high concentration. The synogenic condensation offers very high removal efficiency, often approaching the uh, complete fuse removal. This makes them suitable for industry with the strict emission regulation. Another advantage is the recovery of the VOC in liquid form, which can be reused or processed further. This reduces waste and improve economic and environmental performance. Next is the limitation of the condensation. There is 4 points here. The first one is the high energy consumption, low efficiency at the low concentration, equipment cost, and operational complexity. One of the main limitations of the synogenic condensation is the high energy requirement needed for the cooling. This can significantly increase the operation cost. The process is also less effective for the low VOC concentration, making it suitable as the standalone solution. Therefore, it is often combined with the other technology. So we jump into the hybrid system on condensation with the absorption. The hybrid system combines inorganic condensation with the absorption to improve the overall VOC removal efficiency. Condensation is used as the pre-treatment step to reduce pollutant concentration. The remaining VOC uh, then remove using absorption, resulting in the highly efficient system. This approach is suitable for both high and low concentration conditions. Next, for the performance of the hybrid system, the first one is the high removal efficiency. Next is the reduced absorption load, improved stability, and last one is longer absorption life. The hybrid system improved the performance by reducing the load and the absorption unit. This allows the absorbent to operate more effectively and for the long period. As a result, the system achieved the high overall removal efficiency and stable operation under varying conditions. This makes it suitable for industrial application. For the industrial application, the synerganic condensation system are widely used in industry with a significant VOC emission, including chemical and petrochemical sector. This industry require efficient emission control technologies. The technology is also used in solvent recovery system, where the captured VOC can be reused. This improve both environmental and economic performance. For the environmental impact, the synorganic condensation significantly reduced the VOC emission, helping in to improve the air quality and reduce environmental pollution. This super compliance with the environmental regulation. The recovery and reuse of the VOC also contribute to sustainability by minimizing waste. This makes the process environmentally beneficial. So, in conclusion, the synorganic condensation is highly effective method for VOC removal, offering high efficiency and recovery potential. It is particularly suitable for industrial application. And for the future research should focus on reducing energy consumption and improving system integration. This will enhance the sustainability and economic feasibility. All right, I think that's all for my condensation topic. Uh, Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.